I offer a different view, a view of the universe which has a finite boundary. And that boundary is encountered when all of the mass that is in our universe, including at its horizon, has as much intrinsic energy, we call that quantum energy, as we have always imagined, but that it is bounded by an MECO type, that is a quantum meets physicality kind of equilibrium, where the universe of matter might be pushing out, but the quantum universe of creator is pushing in.
Welcome to another installment of Behind Greatness by Inspire. We are joined again by our good friend, Rudy Schild, Dr. Rudy Schild. We are now recording, this is our fifth conversation. This is our part 5. No less excited than the previous 4. For the listener, I've suggested it earlier. Start at part 1 and move your way through chronologically. And I give that advice only because there's lots of background, rich background that you can gather from those as we go into this one. Or don't. You don't have to listen to me. Who am I? But for the new listener, before we get into it, I want to thank our old listeners and our veteran listeners. We've been at this for 4 years. We're a not-for-profit. None of us derive any income from this. We do this for the pleasure of exploring the what ifs and the why nots with people who have been doing it all their lives. So artists, scientists, athletes, entrepreneurs, and anybody in between. And there are a lot in between. Military folks, ex-spies, philosophers, you name it. So you just go to our website. We're on every major podcast platform. So this now is for the new listener and new viewer, because we're on YouTube as well. Go to our website, behindgreatness.org. You can see the library of content there, all the conversations we've had, or just listen through your podcast, or just watch this on YouTube, whatever you wish. But just please remember, when you get a chance, rate, subscribe, share with your family and friends. We are not-for-profit and a charity as well. So we are always open to take donations, and you can do that through the website. Again, behindgreatness.org. You can see where you can go there. We issue tax receipts to those as well who want to donate. Enough of that. Housekeeping over. Part 5, Rudy. Let's go.
Agreed.
All right. Rudy. Well, number 1, welcome back.
Thank you.
And number 2, this is something that we haven't talked about before, the Big Bang, but we've talked about it in the context of the universe of universes. So I think it was in part 3 where you started to allude to this kind of conversation. You elaborated a little bit in the last conversation, or part 4, but we never touched upon this. So why don't we go straight into it? Universe of universes, right. Big Bang. Tell me.
You got you said exactly the right thing that I was hoping for. In the first place, it is not obvious from any astronomical observation that there ever was a Big Bang. We believe that there was because of the so-called Hubble law, the observation made by Edwin Hubble in 1936, which is Nobel Prize territory, but he was never awarded the Nobel Prize for it. But it's foundational to our understanding of how the cosmos works, and the important observational discovery he made that galaxies are receding from us any direction in which we look. Any direction in which we look, when we see galaxies and they're big and bright, they're at a low redshift. When we see, oh, that's the same kind of looking galaxy at a much larger, much smaller size, then when we measure the redshift is much higher. That is to say, the spectral lines have been brought to lower frequencies or larger wavelengths. And so this means that the further away the galaxy, the higher the redshift. That's a measurable quantity. This is bound to be uniform around the whole sky. And the easiest way to understand this is if we're in a universe that had an explosive beginning, and that's called the Big Bang. Therefore, because of the universality of the measured and known expansion, we've inferred that there must have been a Big Bang. But in 2011, I attended a symposium in St. Petersburg, Russia, and had a private dinner in the company of Carl Gibson, myself. We talked with him, and he said something that's really key and important here. He said, given that there is no proof that the Big Bang exists, we must be open to the fact that something very opposite to that is true. And that is, we might live in a universe where at its distant horizon, there is an attractive field and the universe is uniformly collapsing to its distant horizon. That would create the same effect of the appearance of recession of velocities because the galaxies would be collapsing by a strong gravitational field generated at this distant horizon. And so that would give the observed fact without a Big Bang at all. The Big Bang and the collapse to a distant horizon would be indistinguishable from one another. And so I echo the words of Yurish Beryshev, professor at the University of St. Petersburg, that the universe might be everywhere collapsing to its own distant horizon. Now, this is really important for another different reason altogether. There are some people with mystical knowledge that say to me, you should be open to the idea that the universe was created not by an explosive, mysterious expansion of a particle in a quantum field, but rather it may have been created in a mother-daughter scenario. That would be where two universes in some mixed quantum physical senses intersected with one another. And in the intersection region, that could spawn a daughter universe. So that daughter universe would have the heaviest contents of anything around, and it could be then that the daughter universe separated from the two mothers and is today a universe with a very heavy horizon to which all matter is continuously attracted by gravity, and therefore it gives us a measured Hubble law. So it would be fully fully corresponding with our observations going back to the discovery of Edwin Hubble in 1936.
How does that explain the existence of, or the nascent is the birth of the mother universe?
That was left not understood. It would be that it could be a large, a second, a fifth, a hundredth, a thousandth generation mother universe. In other words, you're asking me, I think, implicitly, would there have to be a first universe that was created by some other means? And there I am left speechless.
Okay. Well, yes.
I cannot say how that happened, but nobody is worried about this except me. Nobody in the whole world is worried about how would you create the first universe and maybe the second one as well. It has to be a mom and a dad, as everybody knows.
Well, you made a point earlier. I mean, the Big Bang theory is a theory, So it's not proven, nor, I'm going to say it, can it be proven? So why not entertain other theories? I think I'm interpreting what you're saying as that.
That's precisely my meaning.
Okay. So why
Anyway,
not? Why don't we?
um, just because that thought hasn't occurred to very many people.
Why not?
But I don't know. It's being taught to every child that there was a Big Bang.
Yeah.
I'm sure that is it not true that when you were in high school, you were taught that the universe started as a Big Bang?
Yeah. Period.
Okay.
Yeah.
So why would anybody question that?
Yeah, we were too busy chasing girls and playing sports than to even. Okay,
Well,
that's our origin. Great.
well, yeah, I hope you were.
One of them unsuccessfully. I'm not going to tell you which one.
You can only get in trouble. We must not pursue this.
Very good, because my kids are listening. I was very good at sports. Can I say that? I just said that under my breath. I hope the mic didn't catch that. So your colleague Gibson.
Yes.
So was he the first? So what is Gibson's background? I had never heard of him, so I wrote down his
Correct.
name.
You wouldn't have heard of him because he's not well known in the realms of astronomy, but he is extremely well known in the realms of fluid mechanics. He was my colleague for a long time because when I understood from observations, we call observations of microlensing, that is to say, looking to a distant quasar and seeing this brightness fluctuate finely. And I would measure that pattern of fluctuations and concluded that this was the identification of the dark matter, that the dark matter consisted of planetary mass objects dominating the universe of physical matter. In the meantime, the theory community has invented another kind of mystery dark matter that's not related to protons, neutrons, and electrons, but rather some other mysterious something that nobody can explain or imagine or draw. It's just a mystery that's there, that's left for them to be able to make sense of the observations of the brightnesses of supernova. I myself don't believe that this other kind of dark matter exists. And the reason that so many people think that it does is that they don't really understand the full implications of my discovery of the normal dark matter, the matter that is protons, electrons, neutrons. That matter has aggregated now in planets, and those planets affect what you would call the opacity or the resistance to radiation in the universe. It is assumed by this community of errant astronomers, it is assumed that the universe is 100% transparent, but it is measured by an interpretation of supernova remnants and supernova observations. It is observed that there's a small defect in the pattern of supernova bright shifts versus the distance. And it's in the sense of the universe being not 100% transparent. Well, the secret is that the universe is not transparent because the dark matter component that I find has made planets, and they, scattered uniformly throughout the universe, act as small lenses. What they do is when a light beam from a distant quasar comes to them, they focus that light slightly in some direction and it goes away from the line of sight, so that the guy at the Earth looking at this just says, oh, the supernova is not quite as bright as it ought to be. Well, what did they do? They invented a mystery dark matter. And because they had no understanding of this, they invented that, well, then there must have been in the past some secondary inflation of the universe. We know they say that there was inflation in the universe, and why shouldn't there be a second universal inflation? And so you get the so-called lambda cold dark matter theory of the universe, which has two gross blunders in it. The blunder was not taking seriously enough the existence of all of the normal matter in a huge collection of Earth-like bodies that cause the universe to be not 100% transparent to the light. And so I differ with my colleagues, and time will tell. But as it stands right now, I'm winning.
Fun.
So we live in a universe which can accept the concept that matter is flowing toward its distant horizon, which is then operating in the vicinity of the space beyond our universe, which is the place of the vacuum zero point energy, which has always been a puzzle. It has always been puzzling to astronomy that when we measure as much mass as there is in the universe, and then we say, okay, well, that should be the same on the outside of the universe, does not compute. Wildly does not compute. Is off by a billion, well, many billions, 120 billion. No, I'm sorry, 10 billions. So there is a vacuum zero point energy. Edgar Mitchell talked about this. It's well understood how the measurement is made. And I take the number to mean, well, the number of universes is probably this billion number. It's 10 to the 120th power, a scientist would say. And if you make the simple assumption that our universe is typical and has a typical mass of a universe, then the universe of universes would just be the sum of all of these universes, and their combined quantum field would be equal to the number of universes.
You ever thought of why we have such an expansive view? Like, why is the universe large? Why does it need to be large?
Yes. Since I didn't build it, I can't take responsibility.
I walk into these things asking these elementary questions. But okay. So let me couch it with this. Excuse the naivete of the question. I should have actually said that first. But have you ever wondered why it needs to be, or why? I'm just repeating the question that way. Have you ever wondered what the purpose is to have a large universe?
You know, I haven't really wondered that, but many people have. And if you go through any ordinary textbook or any university school or university curriculum and ask them, well, how big is the universe? The answer is unknown.
Mm-hmm.
The answer is the universe is expanding. And they cannot answer the question, what is it expanding into? They would say, well, it's creating its own space of understanding, of expansion, I believe. But nobody addresses the question of how big the universe is, because all we can actually observe is limitless expansion. Now, I offer a different view, a view of the universe which has a finite boundary. And that boundary is encountered when all of the mass that is in our universe, including at its horizon, has as much intrinsic energy, we call that quantum energy, as we have always imagined, but that it is bounded by an MECO type, that is a quantum meets physicality kind of equilibrium, where the universe of matter might be pushing out, but the quantum universe of creator is pushing in. And those two in equilibrium are doing the same kind of physics as is happening within our universe at the black hole horizon. In other words, inside our universe, we have these things called black holes, commonly known, and they represent a place where all the physical matter in our universe, and especially that has collapsed from a collapsing body, where that eventually comes up to a quantum block that says, can't go any further. And that's because you're pushing now on all of the force that our universe can sustain, and that's called the Eddington limit. Now, that's a lot of big talk, and I'm sorry about that.
Why?
But we now have it that inside of the black hole is a pure quantum space that's sometimes called a Bose-Einstein statistical assembly of matter. And up against that is this infalling matter that's being drawn to it by the black hole's gravitational field in our physical universe of matter.
Is that Eddington limit where there exists the vacuum 0-point energy?
Not known, and I would say probably not, because its size is clearly estimated by the quantum physics, which ignores vacuum 0-point energy and only talks about the amount of energy that corresponds to the actual amount of matter that we observe in our universe. So, not a good guess this time. I'm going to win this. Remember now, I'm saying that you get this, what we call a magnetic eternally collapsing object, or MECO, by a physical process of physical matter gravitationally attracted, trying to collapse, meeting up with the quantum limit of whatever matter is inside. On the other extreme, you have this matter field pushing outward because stuff keeps falling into it. On this other scenario, the mother-daughter scenario, the expanding universe scenario that I learned about in St. Petersburg. And so that is now pushing up against the vacuum 0-point energy field. And the most obvious interpretation is that's the sum of all of the galaxies in our megaverse. If you want to talk about the next scale of universes, and you want to talk about a universe of universes, then you're in the megaverse.
Well, before we get to the megaverse, before St. Petersburg, before your encounter with this fellow Gibson,
Carl Gibson, yeah.
Carl, is Carl Gibson?
Yes, Carl Gibson.
Okay. So before 2011, what did you believe, or what was your theory that you adhered to?
I believe that it was very flimsy to believe that the universe was unbounded, and yet I had no way to prove that that is true. I also believed in my own observations that the universe's unseen matter, the big dark matter issue of the time, was seen in my observations as a network of planet mass bodies. And I quickly recognized that until you understand that the dark matter of protons, neutrons, and electrons was in this planetary body, then I started pursuing the idea that these might cause the refraction, which causes the departure from supernova brightnesses, and therefore the whole problem is solved without the complicated model of the universe with two flavors of dark matter, and a re-expansion of the universe, which is the standard theory of cosmology today, and which is disproved by the new observations of the Webb Space Telescope. You remember the publicity blitz a year and a half ago, maybe it's 2 years now, when there was a year of engineering work done on the telescope and then the first images released. Every science reporter in the nation wrote his article saying astronomers are scratching their heads. The Webb Space Telescope has discovered this amazing population of galaxies that are luminous and well-formed at a time that the standard theory of cosmology, wrong, standard theory of cosmology predicts a dark age of 400 million years. My colleague, Carl Gibson, realized immediately that this was a gross blunder, that galaxy formation was not dominated by the cute little pussycat problem of the universe acting like an oscillator. And if something goes wrong with the universe, well, a force develops that pushes it back again. Turbulence, on the other hand, doesn't work that way. If you have a local region of space which is a little overdense, just because space is never entirely homogeneous, and then that gravitational attraction working on it gets stronger. There's no little pussycat force that's pushing it back out, because it's too low a density for a sonic force, for a pressure force to develop. What's happening is that gravity is a crisis mathematics. That is, once this little perturbation develops, it feels gravity more strongly, and so it contracts faster and faster and faster and faster. And so by this process, gravity would overtake pressure forces and cause condensations to occur in the universe within 2 million years, not 400 years of dark ages as predicted by the standard theory of cosmology, which was now disproved. My colleagues at Harvard-Smithsonian Center of Physics are trying to pretend that this whole flap did not happen. When the matter of early galaxies comes up, they dismiss it and say, oh yeah, there are some guys that are claiming that there are galaxies at redshift of 13, 14, 15, 16. Well, let them prove it. So that's they're in denial.
What made you not in denial in 2011 when your theory, your thoughts were challenged by Carl Gibson? Like you were well into your career. Like you were 70-ish, more or less.
Yes, I was.
You were on top.
Actually, no. I met him in the 1996 era.
Okay.
And that was when I was first discovering that the dark matter was these planet mass objects. And he was a fluid mechanics expert with not much knowledge of astronomy. He was working with Russian scientists to try to understand the fluid properties of the ocean. And he was an expert on turbulence for that reason, because fluid mechanics is always about the turbulence, stupid. And so I want to tell you that these guys are the ones who really know what they're doing. That is to say, when the United States Navy wants to understand how it can quiet down the operations of its nuclear-tipped missile submarines, they don't go to the lofty ivory towers of Princeton University and ask them, what's up with the submarines? They go to the fluid mechanics community that understands at what point does turbulence develop? How is that described mathematically? How do you experiment with that and verify your mathematics? And what is the theory of turbulence? The Russians are interested in this because their great scientist, Kolmogorov, in 1943, published a theory of turbulence. And now, over the years, that has been found to be the correct theory. And Carl Gibson was the first person to apply this theory of fluids to the Big Bang expanding universe as a fluid, and noticed the discrepancy that
Wow.
there would not be a dark age.
Wow.
So he got me on the telephone, and we met at a dark matter symposium in England.
Of course.
And the rest is history. We've published probably 24 scientific papers over the years showing how much of puzzling observational astronomy is caused by the fact of turbulence that's not accounted for in any of the astronomical discussions of these observations. So I'm talking about cometary knots seen in planetary nebulae, like the Helix Nebula, for example, and other applications like this. He was the expert who first took the theory of turbulence and applied it to astrophysics. That's why he was invited to Moscow with me, and the two of us had audience with Professor Yuri Berezhev, who taught me what I needed to know about the alternative view of the Hubble observed expansion, how that could be actually a falling down to a distant horizon.
You're gonna have to excuse me here.
Just take a deep swallow.
Yeah, well,
Just take a deep swallow.
I have been the whole time. It's still not helping. I say excuse me because I'm going to sound patronizing, and I don't mean it this way. But you know, when I've always been confronted with a professor, a deep researcher and highly cited one, I always imagine, because this has always been my experience, sitting and listening to an expert tell me what it is and how it is. But you're telling me that you were open in being taught different things or having your theories challenged when you were already at the top of your career. So I hate to go back to that, but I want to go back to that because it's a nice little example for the rest of us who, you know, we all of us get into a, I don't want to get philosophical about this, but you know, maybe I do. That's why I'm saying this. I don't know. All of us get a little high on our horses when we know something well. I think it always benefits us when we tone it down a bit and understand that we might know something well, but maybe not well enough.
It worked out for me, since you're asking me for my personal experience.
Of course.
In a significantly different way. It worked out that I became among the most unpopular people in the field of science. And I hadn't ever expected this, but instead of the universe rejoicing at the advent of new knowledge, hurrah, we now understand the dark matter that we see when we study how galaxies rotate and find that there must be some missing component of mass in the galaxies, which is I had just discovered. Do you have any idea of how many people have to be wrong?
Yeah, sure.
When I talk about how this same gravitational theory has a different viewpoint of what black holes are, do you have any idea of how many people have to be wrong? In short, all of them. The entire literature about black holes is simply wrong.
That's a lot of textbooks.
Yes, I'm afraid so. They'll all have to be rewritten. But you see the problem for me.
Sure.
I was not welcome, and people have a very mixed attitude toward me because my results keep being confirmed all the time.
Mm-hmm.
They have, with Carl Gibson, they have been confirmed, the theory confirmed, right and left, and yet the people who are wrong have millions of dollars, some invested in their supercomputers and their operations, um, uh, grinding through again and again the standard equations of mathematics and physics in this lambda CDM theory. So I just have to put up with that I'm the guy who's got a different view of this, and he's best ignored.
So I don't obviously have any experience in this sort of thing. That kind of saddens me, because, well, I'll give it through another example, not in your field, but another example of this. And we have, as you know, we've had a lot of scientists, a lot of entrepreneurs, a lot of athletes, especially at the beginning of this podcast, who were doing things differently, and still exploring very interesting things and expanding the scope of knowledge and experience for humanity. And it saddens me that humanity pushes back. It really does sadden me, because all the inventions that we have had, all the and I mean, I don't know if I can say thought inventions, but all the innovation that we've had for thousands of years usually starts off with somebody who people label as crazy, bananas, a little shift, a little off, but then celebrated when they realize that, yeah, in fact, there's something there that we can all benefit from. But not until after people are long gone do we celebrate that.
That's
Artists
good.
artists are another thing, right? Like how many artists that we celebrate now whose paintings are worth millions of dollars stored in somebody's basement for bragging rights couldn't put two pennies together to save up for a meal, let alone their equipment for painting.
Yes, of course, you're quite right. And it's also true, especially in the world of music.
Sure.
And this becomes a problem because when a new flavor of music came along in the era of 1910, 1920, 1930, and you got into this 12-tone composition and so on, well, you heard the argument, well, you just have to be patient because uh, music takes a long time to get used to, and it will be considered enjoyable in the future. So don't worry about whether you like music now. Is that making sense? No, of course not. And it happened. And the same thing happened in art and painting. In that same era, the 1910s, 20s, and 30s, we had this movement in painting, in art, called the Dada movement, where um, people like artists had been struggling or imbibing in their absence, and in some moments of excitement would just take a clipping from a newspaper, a paragraph that had some coherent thought on it, and putting that in a frame and claiming that that was art. I remember as a 55-year-old being in Tel Aviv and being at the Museum of Contemporary Art in Tel Aviv, and I was stunned to find a art object on the wall, which on closer inspection turned out to be a pair of ladies' underpants.
Yeah, that's weird.
Well, you can see that the artist makes the argument, oh, art is supposed to evoke experience. And I feel that some of the most intense human experience You know the rest.
Well, I do know the rest because I'm a father, and when my boys leave their dirty socks on the floor and they tell me the same thing, I'm supposed to accept it.
Oh,
uh,
we all bear our burdens.
yes, don't we? Don't we? My kids are always creating art. That's one thing I never really
That's right.
realized until now.
Tell them how brilliant they are. That's the only response that works.
It's an expensive existence that they're living. You were we never talked about this. You were hit by lightning when you were younger.
Oh yes. Uh, it was a long story, and I don't know if you really want to talk too much about it. But I was on a mountaintop operating one of these large mountaintop telescopes,
As we all do,
and
sure.
oh yes, as we all do, and it was in the late afternoon on a typical hot summer day in the area south of Tucson, where evening thunderstorms were a daily experience.
Mhm.
And because the day crew was about to drive down the mountain and leave this whole setup all ready to go for that night's observing, one of the members of the crew said, well, Rudy, we're leaving now, and I'll be down in Tucson, but you know, if the lightning strikes the mountaintop, it could hit any of the facility buildings, and my building is connected to the main line of the mountain. And would you disconnect my building from the main line, um, so that my electronics won't be disturbed? And I said, sure, Ed, go ahead. I'll call you if anything comes up.
When was this?
This was in around 1974, maybe
Wow.
1975. So I would have been 35 years
Yeah,
old.
you're a young guy. Yeah.
So I actually also said to him, um, Ed, if anything goes wrong, I'll give you a phone call. And so um, when the storm started coming in, um, I got a phone call from Ed and said, Rudy, I'd like to remind you to disconnect the building. Well, I did go out and disconnect the building, but something odd happened, because when I disconnected the building, I heard the generator that was creating the electricity on the mountain start to ramp up and chug and sound like it was getting on a higher load. It sounded like I was connecting, not disconnecting.
Hmm.
So I walked back to my building and called Ed on the phone and said, Ed, something's not working right. Um, I tried to disconnect the building, but I didn't hear the energy or the generator slow down. It in fact sped up. He said, no, Rudy, that's not right. And it has to disconnect the building. So I said, okay, tell Ed, I'll go check on myself and tell you what, I will call you back in in 5 minutes after I check this out. Just ordinary safety, sensible precaution on a remote mountaintop. I was up there practically alone.
Mhm.
And so I went back and I repeated the experiment almost. I was just looking at the switch in its neutral position and saying to myself, whoa, that's a big, ugly switch. And I used the F word in there too.
Sure.
And I said, I better go back and call Ed. And I started to leave the cage when shut up. Lightning struck the whole business.
Wow.
And and I was I didn't return, and um, Ed got alarmed and tried to call me back on in my building, but there was no answer. And he tried to call back another time and another, and still no answer. Well, there was one other man on the telephone who was operating a different telescope, yet a third telescope. And Ed said, Rudy's missing. Would you go down there and find Rudy? And he came down. Ed had explained to him that he was supposed to be disconnecting his building. The gentleman knew where the disconnect was. And as he approached, he saw Rudy lying halfway down the mountain, boots up. And
Wow.
he found my eyeglasses evidently blown off my head because they were caught in the chain link fence that surrounded the switching apparatus. And he blew the whistle. That is, he called back down and they organized a search party. And they also started manning the telephones at the home base camp, the operations center down in the valley. So
How far were you blown away?
about 10 feet apparently, and I don't really know. I never looked up. By good fortune, this person had been just released by the Air Force, had first aid training, good first aid training,
Wow.
and knew to administer oxygen and try to keep me going. And the first trucks wouldn't arrive for about 30 minutes racing up the mountain. And meantime, down below at the base camp, they were calling around to the local Air Force base. Do you have a rescue helicopter that you can supply to the the government's observatory at Mount Hopkins through the Smithsonian Institution? And they were turned down by the Air Force. But somebody had the sense to call the Forest Service, who, by good fortune, recognized that this was a thunderstorm activity of the kind that they're on guard for because it lights forest fires. And they had actually warmed up a military helicopter in which they would have a crew standing by in case a fire was spotted. They could put it out while that's still manageable. So they sent the telescope. I'm sorry. So they sent the telescope. They
The
sent the
helicopter.
helicopter up
Yeah.
the mountain. And in the meantime, the crew that was on the mountain started to headed over to the site where we have a helipad. It has lights on the side,
Hmm.
and it's a nice helipad for this kind of search and rescue mission. But unfortunately, that day, we had taken a load of transformers, electrical transformers up the mountain, and there was this nice clear spot to unload the transformers, which would be installed the next day.
Of course.
Well, there would be no helicopter parking landing on this place. There was, however, another place not far away where you could measure. They measured the diameter of a clear space. It was 4 feet twice, 4 feet in radius, 8 feet in diameter, smaller than the helicopter rotor blade. So if he set that chopper down exactly right on a wind-swept mountaintop, he could get me off the mountain.
Pressure.
Yeah. The problem was also that there should have been a larger area, but there was a truck parked on the side with a battery that didn't work. And so
all of this, and you were still unconscious.
yes, and this clown show was going on around me, and I knew nothing about it. Anyway, I owe my life to this helicopter who risked his life to get me picked up off the mountain and whisked me up to the hospital facility at the University of Tucson Medical School. And they got me back breathing and going again. And I don't have any memory from this except the moment that I came out of it. I remember recovering to the extent that I saw some overhead lights above me and I saw there were people on my side. I remember saying to myself, oh, I don't want any part of this. And I closed my eyes. And then they did more of the same. And I opened my eyes again. And this time it took, oh, I'm in rescue. Okay, cool.
Okay. Did you think you were on a craft of some sort and people?
No, in fact, I didn't know about such things yet.
Of course.
So uh, um, I do remember also that afternoon I was up and about. I would leave the next day, and that next day somebody saw me, a young man, and asked me what I'm up for, and I said, "Oh, I'm up here because I had to be helicoptered off the mountain because of a lightning stroke." His eyes got big. He said, "What? That was you?" He said. Apparently, a military helicopter set for a crew of 4 to 20 guys makes a hell of a racket.
Yeah, of course.
Apparently, I had no knowledge of this. Who I was dead. I was
Incredible. And so
lights were off.
how long? Yeah. So how long were the lights out, so to speak?
Probably around 20 minutes.
It's a long time.
Yeah.
But you're getting oxygen the whole time.
They were giving me oxygen, and I was, I think, partially breathing. They explained to me later on it was a very irregular breath, and it had all of them crossing their fingers. And it's very blessed. I owe so much to this crew for getting all and taking any risk and getting me safely off the mountain to a medical supplier.
Do you know if they're still around, the helicopter pilot and the former Air Force guy?
I don't know. I haven't been back to the mountaintop for 20 years now. It's considered still a somewhat dangerous place. And when I was 60 years old, I got retired. And in retirement, you don't do 11,000-foot mountaintop work anymore.
It's for young men.
And so I retired to the Cambridge office complex.
I know we talked about near-death experiences. Actually, I don't know whether we recorded a discussion on it, but you and I talked about it earlier on when we first met each other. And there is a story on this podcast. There's a surgeon. I'm not going to relate the story, but just to share it with you here. It's episode 55. Tony Chicoria. He's a retired surgeon now, orthopedic surgeon, and he was on the phone, a payphone, 1994, with his mother, and lightning hit the building. And the current traveled through the phone. And at the moment he came out of the phone, he realized he was toast. He knew exactly what was happening in that split second. But then he relates, it was a good 15-minute story about what happened when he got hit by lightning. And I'm only going to say this. He said, Luciano, my body went backward, but I felt propelled forward. Wonderful story. Wonderful story.
In fact, that's the experience of going to the distant horizon of our universe, which is the end of your universe experience or your terrestrial experience. We haven't talked about this, but
let's go.
Okay. What I mean to say is that in this structuring of matter, where we live in a universe that has these collapsed, condensed objects called black holes. And these black holes, I may have explained to you, become nature's hard drive because in their outer surfaces, they store up the contents of the quantum hologram describing everything in our universe. And that quantum field record means that within our universe, the entire past of our universe is being recorded as you go deeper and deeper to the core of the black hole, where you get this Eddington limited field. So in the case of the opposite, which is the distant horizon, time flows the other way. time enters the universe as the possibility of events at the distant horizon and makes its way slowly to our daily experience. And people who have near-death experiences and other mystical experiences talk about there being timelines. That yes, there is some kind of connection that connects the future of my human experience and my human consciousness. They're called timelines. And we can understand that the distant horizon is expressing the intent of the creator of the universe, which we've described previously as the purpose of the universe being for life to exist and thrive. And those timelines express that intent of the universe, but they eventually come to our locality and they affect us by creating the moment of instantaneously now, creating the now moment. And our physical being can take the nudge from the universe of what the timelines are wanting us to do, but we have the choice to do what we think is appropriate for us. And so timelines meet human experience, and history is the outcome. The outcome of time entering the universe, the human experience of consciousness creating the now moment, and the purpose of the universe meeting physicality and the human experience and consciousness, and that being the having the outcome of
History.
of physicality, of our physical existence, and the manifestation of the purpose of the universe. Whoa.
But once we leave our bodies, once we leave
That's
the
right.
physicality, but once we do, are we not yet still part of the purpose of the universe?
Yes. And so that person, I think, described what? That he was living in past time or he was seeing future time?
No, is that he was existing beyond time.
Beyond time.
Yeah.
Mhm. That would be the experience of being no longer physical and being and joining with the eternal soul, the eternal being.
Yes, and there is something else in that story. You're not going to believe me here, but I have a three letter word, and I circled it because I've been wanting to talk to you about this since episode 1. So I've pushed it over like many other things here. But it reminds me of this story. He describes what he saw, what he felt, what he heard, where he was going. So he felt this compunction to go in a certain direction. And he said, so I'm not going to give all those details. The listener can go have a listen. That he did turn into a ball, not a ball, a sphere, a lit sphere. And I forget the term that he used. It could have been offline that he told me, but I remember. I'm taking it from my data bank here. A white sphere of light. That's what he was turning into. He felt himself that. Funny. It's so funny that I didn't even mean to bring that up. I wanted to ask you, I've been wanting to ask you for a long time because I heard you mention it once in a conversation that I was listening to before I even met you. And I want to ask it here. What is what people call an orb? There's that 3-letter word. Because we've had people on the program give their experience about seeing one and their family members seeing one.
Yes.
Eh,
And even photographing them.
on the program, this one particular person, I'm not going to say who, showed me pictures.
Yes. I
Um,
have seen the pictures. And I was unhappy, that is to say, searching through for a physical possibility that could explain it. And I thought, this is with the photographic camera. I wasn't there. I didn't see this, and I didn't inspect the lens of the camera. If you had a spot of dust or dirt or something on the camera, that could create an out of focus image, but I couldn't explain why that would be apparently self-luminous, unless there was a bright light somewhere and it was reflecting bright light, and you had many dust particles on the lens and didn't really think about it because it was taking pictures fine. So I filed it away as orbs could be real and actually having about this size typically.
Sorry, for the camera, you were forming something here with your hands, but I didn't see it. It was off camera.
Okay, so orbs could be something about this size.
So like the size of a
something
softball.
like a softball, yes.
Yeah.
Good, very good.
Okay.
And incidentally, that's also the size of a human brain.
Yeah.
So I have always thought that this really relates to the theory of what consciousness waves are and look like, as was described by scientist Wilhelm Reich, operating in the 1950s and 40s and 30s era, where he said that he could see consciousness waves, and they were of two kinds. There were the ones that had a shape of a rotating something like a spinning wheel. It looks like, if you would imagine and seeing it all at once, it was a spring, an automotive coil spring. So a coil spring that's advancing at the same time it's turning around. There was another kind of wave that this scientist Wilhelm Reich related to as consciousness waves, and it was doing circular motion again, but with increasing radius of the circle. It was expanding out to bigger and bigger sizes in the universe. And I have always carried that in the back of my mind because of the successes of his writings and teachings, that these two probably are related to consciousness, as he says, and that the one that is constant in radius, the coil spring, the automotive coil spring, just going on infinitely as far as we know, that could be understood as something that the human brain makes, and it goes out because it's on the scale of the human brain and never leaves that scale in our universe. This other kind is very interesting to me because if you think about it, expanding as it's going, well, then it begins to look like the structuring of all the matter in the universe. Wherever we look in the universe, we see matter being structured basically spherically. Sometimes you get pancakes, but mostly you see like a cluster of galaxies that's basically spherical. Or you'll see a cluster of stars that's basically spherical. The universe makes spheres on all scales. And so we now know that consciousness is born by these waves. I call them type A for the coil spring and type B for the expanding one. Those can produce the entanglements that are intrinsic in the consciousness theory. Remember, we say that entanglement is an experimental fact, that in our universe, we see the physical matter that obeys the Newtonian physics laws, but we also see another set of laws called the quantum mechanics operating in the universe, was discovered working on the atomic scale, and eventually became understood to work on the human scale. And now we're starting to see how it can work on the astronomical scale.
Hmm.
So that will create entanglements that encompass the entire universe. And that makes quantum mechanics a force or a entanglement operator that can deal with human consciousness, spread it, or create it, or destroy it for all time. So these waves and waveforms are very, very fascinating, and nobody has taught this to me. I've never heard this anywhere. This is all the sense that I'm trying to make of the history of science, the history and practice of contemporary astronomy, the scientific work of Wilhelm Reich, and the stories that people who see flying saucers and have expanded brains also are describing. And so this person that you describe who had the near-death experience, there's a good chance if you talk to him about this openly, would tell you he's had other near-death experiences or has shown other gifts of intuition or expanded brain function. He's probably a very spooky person who can read your mind or has shown skill as a horse whisperer or a bird whisperer, things of that kind. This is all the workings of entanglement and the quantum attribute of our universe.
I implore the listener to go to episode 55 because the answer is yes. So the listener will understand what he was left with and what he decided he had no choice in pursuing because it was indelibly marked with it after this experience. So
yes, it was actually patterned in his brain function.
Mm-hmm.
What happens is that exposure to the UFO, but other things that are related, intimate contact with this quantum field generates within your brain new neural networks and brain connections such that your brain is forever marked by expanded possibilities. And this manifests itself, as you say, with what Rey Hernandez in his book on UFO abductees, as the contact modalities. I previously lectured and talked about them as the modern miracles. The things that we see in biblical time described and just call them miracles. But people are having these miracles today, and we're starting to pick up on our lingo and say, well, that's some kind of entanglement mechanism.
Mm-hmm.
Okay,
not coincidence.
Yes, and it affects your brain, and you become an expert at things you weren't expert at before. Things like you have intuition. I have friends who can have a twin brother, and if they just get an inspiration that they should talk to their brother, they pick up the phone, and he's just picked up the phone, and they take up a conversation. Now that's an entanglement, you see.
As you know, we've had Garry Nolan here on the program, and he is actually studied. He was approached by folks who worked at the Pentagon to actually study the brain activity of people who have had these kinds of experiences. And he's a professor at Stanford, as you know. I would look forward to having the two of you together talking on the
Yes.
program. That would be a treat. That would be a treat for our listeners, I think. For me too. We've had Matthew Roberts on the show recently, and I alerted you to the episode that we had with him. I think it'd be a cool discussion. It doesn't need to be a long one, but a cool discussion to have us, the three of us, on the program, because he's had these experiences.
Yes, and I would enjoy that, and it might be therapeutic for him to realize that within the framework of science today, in particular, within the framework of entanglement in a universe whose mass structuring is entangled, that it's okay for him to enjoy that expanded range of possibilities of his brain.
Well, so why don't we do this? We'll leave it off right at this. We'll see what we can do here. I mean,
all right.
We'll reach out to him. I mean, if it doesn't work, it doesn't work. But either way, we're gonna hear more of you on this program too. So part 5 is not the last.
Make it so.
All right.